For our project, we decided to focus on freefall acceleration and terminal velocity. We wanted to see how terminal velocity changes with different masses. Freefall acceleration is when an object moves under the influence of gravity only and no other forces. It is always directed vertically downward. Terminal velocity is the constant speed that a freely falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. Drag is the sum of all the aerodynamic forces in the direction of the external fluid flow. It acts to oppose the motion of the object. For our experiment, we used a tape measure, painter's tape, a food scale, a ruler, and 5 cupcake liners. The ruler was used to find the diameter of the cupcake liners. The food scale was used to find the mass of 1, 3, and 5 cupcake liners. We then used the tape and tape measurer to mark 1 meter off the ground. That way each drop was from the same height. In this section, we dropped 1 cupcake liner from the preset 1 meter height. After recording the fall, we ran it through the video analysis app. From the app, we were able to obtain enough data to create a time versus velocity graph. This graph then showed us the terminal velocity to be around 2.2 meters per second, as shown in the highlighted region. When we dropped 3 liners and ran it through the analysis app, the data collected ended up giving the graph as follows. The 3 liners did not reach the terminal velocity. For the last part of the experiment, we dropped 5 cupcake liners from the preset 1 meter height. After doing this, we ran it through the video analysis app, and again, the graph showed that the 5 liners did not reach terminal velocity. For each of the trials, we calculated the predicted terminal velocity values for the cupcake liners. We used the equation at the top left and filled in numerically with the data we had to obtain the 3 predicted values. At this step, we had to pay close attention to the units as everything had to be the same in order to cancel out at the end to get meters per second. Once the trials were finished, we obtained our experimental values for the terminal velocity and compared it to our predicted values. Now that we have obtained both our theoretical and experimental values, we use the percent error equation shown to see how close we were to the actual terminal velocity values. Since the trials with 3 and 5 cupcake liners did not reach the terminal velocity, we only calculated percent error for the 1 cupcake liner being dropped. This resulted in a percent error of 32.38%. Sources of error could have emerged from the data points collected in the analysis app. Overall, we are satisfied with how it all turned out.